A very good evening to all. Center of Excellence in Safety Engineering and Analytics, CoE-SEA, welcomes all its dear participants to Week 34 Weekend Talk on Safety Engineering Management and Analytics. The program is conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence. We begin this event with this beautiful sloka. Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityoma Amritam Gamaya. Praying to God to lead us from ignorance to truth, from darkness to light, and from death to immortality. The center is organizing an online short-term certificate course on prevention through design and redesign to ensure product and process safety from 24th of January to 29th of January. All those who are interested can please get the more information and registration from our website. Please note the last date for registration will be on 23rd of January. Now let me welcome our dignitaries to the virtual dais. We have with us today Professor J. Maiti, the chairman of the center, and Professor O.B. Krishna, the convener of the Weekend Talk, and our expert speaker for the day, Professor Vishwajit Mahanti. Professor Vishwajit Mahanti has obtained his B.Tech degree in Mechanical Engineering, M.Tech and PhD in Industrial Engineering and Management, all from IIT Kharagpur. He has a rich and varied professional career with over 6 years of industrial experience and more than 30 years of teaching, research and industrial consulting work experience. His areas of work include system dynamics, operations research, information systems, supply chain management, decision analytics, and safety archetypes. He has guided 20 doctorals and over 200 UG and PG level dissertations. He has carried out more than 20 industrial consulting projects and 10 sponsored research projects. He has about 100 publications in well-known international journals as well. He is also an author of the book Responsive Supply Chain, published by the prestigious CRC Press. He has developed a 29 lecture NPTEL course on MIS and 40 lecture NPTEL course on decision modeling. He was a visiting faculty at the School of Management at AIT Bangkok. Besides being a professor of the Department of Industrial and Systems Engineering, he was the Dean of Planning and Coordination of IIT Kharagpur from the period of 2013 to 17 and was the head of the department for the period of 2009 to 12. CoE-SEA wholeheartedly welcomes you, sir, and we are very privileged to attend to. Now, I kindly request Professor Maiti to formally welcome our expert speaker. Over to you, sir.
Thank you, Swin. Thank you, Professor Mahanti. What I can tell about you. So, we are extremely benefited and privileged to have you today with a wonderful topic, decision analytics. And this is an evergreen topic, and you are doing research, teaching, consulting in the decision modeling for several years. We all know that today it will be an excellent talk for all of us, and we will be extremely benefited. Regarding Professor Mohanty, I will not introduce more. Swin already introduced. He is B.Tech, M.Tech, PhD, all from this institute, IIT Kharagpur. And I strongly admire him because of his excellent teaching, excellent board work, and the knowledge, particularly in his areas of research and teaching, as well as other areas of industrial and systems engineering. He is extremely knowledgeable person. Whenever in my entire 19 years here till today, whenever I missed any concepts, I used to go to him, and I'm telling you that I was immensely benefited by his that clarification. And you will also notice today all those things today. So with this, and as you know, sir, you know that CoE-SEA established in for particularly a noble cause, that we want to see that people at work in particular and people at larger societies, they will be safe, they will be healthier, and this kind of undesired events should not happen to anybody in the industries or societies. And collectively, loss prevention, societal loss prevention point of view, our CoE is working on this. With this a small that introduction, I request Professor Mohanty. He is my department colleague, and he was actually head of our department, and also he was dean. And in fact, he is very prominent personalities, not only in IIT Kharagpur, that out of IIT Kharagpur in India and across the world. Sir, you please start your, with this, I request you to start your lecture.
Right. So thank you very much. And I'm really very happy to start my lecture today. So in this particular lecture, that is, decision analysis, decision analytics, learning through systems archetypes. Let me begin with a brief introduction. Just 1 minute. Yes. So brief introduction. Now, when it comes to the decision analytics, see, there are many tools in decision analytics. Is it all right? So beginning from operations research to genetic algorithms, and when we talk about operations research, there are many tools like linear and nonlinear programming, heuristic programming, and so on and so forth. But in this particular lecture, we focus here on a very specific methodology called the system dynamics. So in system dynamics, this is a methodology of social system analysis and design at the aggregate level using continuous simulation. Now, look here, what exactly I mean by aggregate level is that the decision making at that level of decisions, which is at the top level of management, is all right. The kind of decision that is made for the strategic level. So it was developed in late 1950s by J.W. Forrester at the Sloan School of Management at MIT. As you can see that it addresses long-term issues, models feedback processes, models soft social and psychological variables. See, most of the quantitative models, they have the limitation that they can only handle variables which are highly quantitative in nature. But moment we have qualitative model, moment we have situation where data is not available, that is where the system dynamic simulation methodology is very, very applicable. And it uses continuous simulation. See, it is not discrete event simulation, it's a continuous simulation that we use to test effects of alternative policy options. The kind of discussion that we are going to have today will be focusing not so much on simulation, not so much on projecting behavior over time period. I will not even show any equation. I will only focus my discussion today on the feedback processes. Try to understand that in a 1 hour lecture, it's really not possible to give a total idea of system dynamics, because then I have to also discuss how we develop equations, how we develop different kind of diagrams. That I am not really attempting to in this particular lecture. My focus will be on the feedback processes alone. Now, systems thinking is at the heart of system dynamics. So what is this systems thinking? Systems thinking essentially talking about holistic thinking. Now, holistic thinking is what is whole then? We know that whole is a combination of parts, but not simply the parts alone. Suppose you are given a car and you break it apart, small components, and you then put them all together, it will not become a car. Those components, when they are organized in a certain manner, then only that car will be resulted. So that's the thing, that it is parts plus something that makes the whole. Now, parts plus, when I say something, what is that something? There's something are two things. One is called synergy, another is called emergence. What is synergy? Synergy is building something into those components so that the components work in the best possible manner and for the intended purpose. And what is emergence? It becomes something which is not never possible with the parts. For example, if you just get a steering wheel, you know that yes, it is used for driving a car. But when you actually drive a car, then only you understand what is a steering wheel. So that's what is emergence, right? The steering wheel emerges to another level when you get the whole car. When you get the steering wheel alone, you can never understand how that steering wheel feels when the car is in motion. The second point is that system structure influences system behavior. See, this is a very, very important statement. What exactly we are really talking about is that it is the structure. If you can want a particular kind of system behavior, you have to really have a particular kind of system structure. And therefore, if you really want a behavioral change, you have to bring in a structural change. And how this structural change can be brought in, because you must remember two things. One is that policy resistance. Usually large systems, they resist the implementation of policies that you have seen many times in real world. And the second thing is, you must also know that where are the root causes and which root cause should be attempted at, so that the highest leverage can be achieved. So those are also very important. So what is really therefore required for systems thinking is bring about metanoia. Meta means above or beyond, and noia is of mind. That means a shift of mind. How this shift of mind could be possible? This shift of mind can be possible through systems, archetypes, and simulation. So that is our main topic today. That is systems archetypes. Right? What are systems archetypes, and how systems archetypes are useful in various situations, particularly in the area of safety. Further reading, you can read this excellent book, although little old now, but at the same time, this importance has never subsided. The Fifth Discipline: The Art and Practice of the Learning Organization by Peter M. Senge. Right, an excellent book, The Fifth Discipline. If you can get hold of this book, definitely you read. Most of the material that I am covering today is taken from this particular book. But then let me also tell you another thing. The two major areas where system dynamics has flourished, one such area is at UK, and the other area is in US, particularly in MIT. And as you know, like, we call Industry 4.0 and we call smart manufacturing. The smart manufacturing and Industry 4.0 is the same thing, but, they are said in the two different continents. Similarly, that, the ideas of systems archetypes are slightly different. As the people like Peter Senge, what he says in UK, and the people like, MIT, people at MIT, what they talk about systems archetypes in US, the concepts are same, the ideas are same, the presentation is different. All right, so there are certain lessons of system dynamics which will be useful to us. First one, the structure influences behavior. Systems cause their own crises, not external forces or individuals' mistakes. Right? So most often we forget this. We try to find out some external forces that because of that it has happened. We forget that it is the system that we have created that is responsible for the crisis. So if an accident has happened, if a safety situation has occurred, then question the system, do not question the people, or do not question the event. That event is inevitable. If it has not happened today, it would have happened tomorrow. Structure in human systems is subtle, not just basic interrelationships that control behavior, but how people make decisions is very important. So, what exactly goes in behind the decision that human make, which has caused this particular system structure, again, which is responsible for behavior. Then I talked about the leverage. So that means if we want to bring a change in behavior, we have to bring a change in structure. Now, how this structural change could be made? The one way of making a structural change is to change the human behavior styles. The other is understand where is the leverage, what are the root causes, which cause is to be focused. Like it is said that its chain is as good as its weakest link. So if you can focus on the weakest link, you can break a chain. So if you really want to change the structure, you have to understand how the present structure is bound together. What are its feedback processes? And if you have to break that chain, you have to find which one is the weakest link. So that is exactly what you try to focus. So these I'm going through very quickly. I'll not really try to focus on that. Only some of these things, if you read, like problems are coming from yesterday's solutions. Harder you push, the harder the system pushes back. Behavior grows better before it grows worse. The easy way out usually leads back in. The cure can be worse than the disease. Faster is slower. Attempts to expedite the control of the long term behavior of a system leads to adverse results. The root cause and the effects are not closely related in time and space. So all of these, the systemic things can be resulted in various such processes. Very briefly, I talked about the broad perspective in which our discussion will be centered. Now, let me come quickly to the feedback processes, essentially the ideas of cause and effect. Now, look here, most of us, we think that cause and effect are, something like, the whole thing has happened, a safety failure has happened. What is the cause for that? So when I say cause, I don't mean that particular thing. What I mean is assuming a steady state condition for the model when a change is brought about in a variable A, and if a resulting change comes in an immediate and adjacent variable B, then we say A causes B. So what is A causes B is essentially, if we have two variables and those variables must be immediate, means in the same time, in the same space. So that is that adjacence. And also in the same aggregation level. That is, what is that aggregation level I'm talking about? Supposing you are really making a model of the population of India. So when you are talking of population of India, the birth rate of the Indian situation and the death rate of Indian situation, they both are causes for the Indian population to go up or go down. But you can also think of this problem as an agglomerate of several states of India. You see, India has more than 30 states. So, if you look at individual states, in individual states, what is the birth rate? What is the death rate? What is the population? What is the mechanism of that particular state? And India is an aggregate, the behavior of all these 30 states. So if in that situation, the birth rate of one state will actually, change the population of that particular state only. But when it comes to the Indian population, it will be a aggregation of the whole thing. So question is that your model is at which level of aggregation? That would determine what is meant by adjacence. Supposing we are making a model, a very small model of your shop floor only, and within that shop floor we are talking about some kind of safety incident, then we have to take variables which are related to your particular shop floor, right? And you have to take variables where one variable is directly affecting the other. So anyhow, so given in that kind of thinking, so here are some examples. more production, more inventory or stock, more birth rate, more population, more depreciation, less capacity, something like that. So this is, but then you see, I am differentiating this kind of causality with other kind of causality, which I am calling as direct causality, like quality, more sales, more skill, more productivity, more price, less demand, right? So you can see that minus sign. So price is more, demand is less, quality is more, sales is more. So like that. So what is the difference between this conservative consideration and direct causality? So first of all, this production is, a flow of material. The birth rate to population is a flow of people. Depreciation to capacity, a flow of capacity. So here, as if you produce, that means some material, those material will add to inventory. A physical thing is moving, right? And that physical thing is accumulating in a particular stock. So that is the kind of causality that we are calling as conservation consideration. On the other hand, the direct causality is slightly different. Here, things are happening through an information. See, when we say that more price, less demand, nothing is moving here. It is not that the price variable changes or demand variable, something is added to the demand and something goes down from the price. This is basically the information of price changes the demand. It's all right. So they are slightly different way of looking at things, right? So examples of causal chain. So they can also form a chain like price, demand, more price, less demand, less desired production. So you see, you have to read two at a time. More demand, more desired production, but less demand, less desired production. Now, more price, less demand, less desired production, less desired production, less inventory. So, if you read only two at a time, more demand, more desired production, more inventory. That is the meaning of plus. Like here, more skill, more productivity, more production, more inventory. So, this is a causal chain. But then sometimes there could be more than one variable may lead to a causal chain, like order backlog and inventory, both may be the reason for sales rate. Potential demand, quality, and price, they all can, lead to orders received. So now we come to the feedback loop. Now you see the causal chain can be formed, right? X causes Y causes Z, and Z again causes X. So here you see a feedback loop is a closed sequence of cause and effect, the basic unit of system structure and analysis. So when I talk about system structure, essentially I mean the presence of feedback loops, their polarity, their gains, and the the kind of what you call, whether they are positive feedback loops or they are negative feedback loops, that is also going to be very important, and also the dominance of one feedback loop over another. So all of these are going to decide a system structure. So that's what I said, that if we are having a particular kind of system behavior, that system behavior is a function of system structure, and the system structure is consisting of feedback loops. So therefore, that feedback loop is the basic unit of system structure, right? That is the essential idea that we are talking here. And a feedback loop is basically a closed sequence of cause and effect, like X causing Y causing Z, and Z causing X. Now, these X, Y, and Z, they should be immediate and adjacent in the level of aggregation and immediate in time, right? And the idea is when everything else is considered to be in equilibrium, and a small change in X, incremental change in X, is going to make an incremental change in Y. That is how we are defining causality. Now, sometime what happens that there could be an effect of a time delay as well. This is going to make the difference. X causing Y, but then after some time. This after some time is very, very important. Supposing you have, like we are in academic institution, suppose the government tells us, let us have more students passing out of the academic institution. But more students will pass out of the academic institutions only when we are going to admit more students at the, initial level. Question is, supposing our every year intake is 1000, we make it 1200. After 4 years, 1000 students are passing out. Will the next year we are going to have 1200 students passing out? Answer is no. Why? Because look here, we have increased our intake from 1000 to 1200, but additional students will pass out only after 4 years. That's what is time delay. And this time delay plays a very, very big role in the effect of the behavior processes. Yes, X is causing Y, but after some time. Is it not? So supposing you find that your capacity is less. If your capacity is less, you are unable to meet the demand. So you decide, yes, we'll change the capacity. But then capacity change requires two delays. What are those two delays? One is understanding that yes, capacity should be changed. And second is that after yes, you understand that capacity has to be changed. Uh, at that time, you are only you have to decide that order the capacity. Again, there will be a delay, that is the supply delay, before that actual capacity will come. I recall when there was this OBC reservation came into the IITs, the student strength have increased suddenly. And it was a very difficult time for the institute because the institute has to really cater to large number of students with the existing capacity. Now look here that the kind of capacity increase has taken several years before we really got the kind of capacity that should be there for increased students. Several years. So these several years really has gone through a turmoil where the number of students are more, the hostel capacities are less, the classroom capacity is less. So therefore, you see that kind of turmoil, kind of difficulty the students faced, the faculty members faced, the administration faced. It is all because there was a sudden increase in the capacity, sudden increase in the number of students. But our other infrastructure facilities took time before they could come to the terms. All right. So that is the thing. Then after that, let us see another. See, this is a very popular thing. That's the population dynamics. So more birth, more population, more death, less population. There is a particular meaning for these two colors. This red color is something. I mean, the purple color is something that is universal in nature. If there are more births, then there will be more people. And if there is death, there will be less people. So that's the universal part. That's the conservation consideration, this purple part. The blue part, on the other hand, if there is more people, we can assume that there will be more births and there will be more deaths. Right? That's the sheer force of numbers. So assuming the birth rate is at 1.4% and the death rate is around 0.6% per year, so the birth rate will be a certain fraction of population and death rate will be certain fraction of population. So that creates two feedback loops: more births, more population, more births, and more population, more death, more, less population. So that's the balancing loop, and this is the growing loop, right? The growth loop. The point is, overall, so should the population increase or should the population decrease? In countries like Africa, in countries like even India and some other, Asian countries, the population is increasing. But in some countries, in East Europe, some countries in like Japan and other countries, the population has become steady, and maybe in few years they may even go down. Is it all right? So you can see that it depends on whether the birth rate is, what is the dynamics between the birth rate and death rate, what is their relationship. Anyhow, so like that you can think of various level of population dynamics. So here is another example of a positive feedback loop. More sales, more satisfied customers, more satisfied customers, positive word of mouth, positive word of mouth, more sales. All right. So you can see more sales, more satisfied customers, more positive word of mouth, more positive word of mouth, more sales. So a positive feedback loop. Now the question is, does the system has these only one positive feedback loop? Answer is no. The system is having many such feedback loops, and the total behavior is a combination of all these different feedback loops. So sales continue to grow, resulting from positive word of mouth from satisfied customers. So these kind of feedback loops are called positive feedback loops. Sometimes we call them as growth producers, or sometimes we even call them as reinforcing feedback loops, right? With a symbol of R. On the other hand, the balancing kind of loops, which are called the negative feedback loop, you know, more orders, more supply line, more are materials in supply, more materials in supply, more is the current inventory level. And supposing we have created a control system, we see the difference between the desired value and the actual value, use it as a control signal, this perceived gap, to placing the order. So we have created a balance. That means more orders, more in supply, more in supply, more inventory, less gap, less gap, less orders. So that's the kind of balancing loop or the negative feedback loop. So balancing process for adjusting inventory to desired inventory level using perceived gap as controller. All right, so this is another example, the capacity example I was giving earlier, that capacity decision is there, but there is a delay before the capacity is there in transit and the capacity level increases. So yes, the balance will be achieved, but after some time. All right. So here is a one systems archetype which is called the fixes that fail. So we'll discuss fixes that fail later in some more detail. The essential idea of that fixes that fail is that there are two kinds of feedback loops that is available. Supposing there is a safety problem, the safety problem require an actual solution, but this actual solution will take some time before that can be implemented. In the short period, we go for some kind of an easy fix to solve this safety problem, and that safety easy fix, reduces the crisis. So as so, safety problem, more easy fixes, less crisis situation, less safety problem. The balance is achieved. But these balances, ultimately doesn't help us, because, these easy fixes after some time creates another situation. What is that situation? Inability to go for actual solution. We are tied to the fixes only, and we try to use a bigger fixes next time instead of trying to really solve the actual problem. All right, that actually adds the crisis situation. So there is a positive loop on the bigger side: more safety problem, more fixes, more inability for the actual solution, more inability, more crisis, more safety. Now question is, when there are multiple loops, one positive loop and one negative loop, we have to analyze that which loop is ultimately going to be more dominant. Will the negative loop be more dominant or the positive loop be more dominant? If you analyze this, you will understand over long term, while the negative feedback loop will be dominant, in the initial period, in the long term, the positive feedback loop will take over. Is it not? That positive feedback loop will be taking over, and that will be dominating, and overall behavior pattern will be that of the positive feedback loop and not negative feedback loop. Now you may be asking me that how am I saying all this without putting values, without doing simulation, without doing any kind of calculations. I am saying it with a little bit of experience, and I am saying because I have read some published literature. That is the only reason, and nothing else. All right, so I know in this kind of situation, this is exactly what happens. So there could be a little bit of analysis also, which is called the feedback loop analysis. But obviously, in 1 hour lecture, I cannot really talk about so much in detail. Only thing I can tell is a very, very important part of the feedback loop analysis is understanding the level of loop dominance. Is it not? That is what is a very important thing. Let me write what I am talking about. I am talking about loop dominance. So it is not only, so you see, it is not a simple mathematics that I have one positive feedback loop and one negative feedback loop, and therefore the behavior will be like this. No, not at all. It is which loop is going to be dominant. In another situation also, I have shown few minutes back, I have shown you that there was a positive feedback loop and there was a negative feedback loop in the population situation, the birth rate and death rate. Right? The birth rate gives a positive feedback loop and death rate gives a negative feedback loop. But there also, it is not that the positive loop is dominant or negative loop is dominant. Both the loops are equally affecting the system at all points of time. It is what is the relative strength of the positive loop or the relative strength of the negative loop. But here, the positive loop clearly dominates over a long period, and therefore the negative loop actually, that is because the positive negative loop can no way change the effect of the positive loop. Anyway, all these things we can see later. Now here is a particular structure I have taken directly from the Business Dynamics book by John D. Starman. Starman is a MIT Sloan School of Management professor who has, in his book Business Dynamics, he has given this particular diagram. So you can see what really happens in a project management situation when there is a schedule pressure. The schedule pressure that has been developed, uh, you know, the people invariably they go for overtime work. So as they do overtime, the completion rate becomes faster, the work remaining reduces, and the schedule pressure reduces. Is it all right? So that's a balancing loop or a negative loop. More schedule pressure, more overtime, more completion, less work remaining, less schedule pressure. So you see, that's a balancing loop. That's what that B1, and he calls it midnight oil burning. There is another balancing loop here that is called corner cutting. Why? What is the corner cutting? As the schedule pressure is developed, we put less time per task. So as we give less time per task, the productivity goes up. As the productivity goes up, completion rate goes up. Completion rate goes up, work remaining goes down. Work remaining goes down, schedule pressure goes down. All right, that is another balancing. This is called the corner cutting. So with midnight oil burning and corner cutting, we reduce the schedule pressure. But we forget that two more things are happening after some time. If you keep on working overtime, after some time, you develop fatigue. As you develop fatigue, your productivity falls. As your productivity falls, your completion rate falls. Work remaining increases, schedule pressure increases. That's called the burnout. So this is the positive feedback loop or the reinforcing loop called R1. This is what is happening. The fatigue kills the productivity gain. The fourth loop here is called the haste makes waste. As you cut time per task, your error rate increases. After some time, productivity falls. Productivity falls, completion falls, work remaining increases, schedule pressure increases. So, really speaking, those advantages you gain initially by midnight oil burning and corner cutting get more than compensated by burnout and by haste makes waste. There are several such situations in project management where such methods have actually fallen, right? Actually, not given the results that they are interested in. Now, there are various systems thinking tools, so we shall go very quickly about them. You all know that this Ishikawa diagram or that fishbone diagram, everyone draws them. Behavior over the graph, then causal loop diagram, we are just talking about them. Systems archetype, that's what we are going to discuss further. Graphical functional diagram, structure behavior pair. Uh, I mean, structure causes behavior. So this is structure, this is going to be the behavior. Policy structure diagram, how the policies are made in real world. So this is kind of diagram. The computer models, here is a complete system dynamics models. Then management flight simulator, that is a gaming kind of situation which helps us foresee the action of our policies. Learning laboratories, developing kind of experimentation versus reflection dynamics, all of these. So these are all systems thinking tools, and our focus is on one such thing called systems archetypes. Now, there are different large number of systems archetypes. Only 8 have been listed here as per the MIT. These are they when they teach systems archetypes, they teach these basic 8 systems archetypes. But that doesn't mean that there are only 8 systems archetypes. You can think of different other systems archetype. If you go through the literature, you may find so many other systems archetypes as well. But anyhow, these are some basic systems archetype like fixes that fail, shifting the burden, limits to growth or limits to success, drifting or eroding goals, growth and underinvestment, success to the successful, escalation, and tragedy of the commons. Right? So each one really requires a particular thinking. In a sense, they are all, what are they? They are nothing but causal loop templates. And those templates tells us what are certain systemic behavior pattern that one we should be always aware of. Because in many such situations, those kind of systems archetypes are invariably going to come. We should be aware where we are falling prey to this kind of systems archetype. In the given context, I shall be discussing only 3 of them. That is the number 1, fixes that fail, number 2, shifting the burden, and number 4, drifting or eroding goals. These are the 3 that I am going to take up. So fixes that fail, already I told you, I have already shown similar diagram. There is a problem, the problem can be solved by a fix, more problem, more fix, the current situation is taken care of for the problem to be resolved. But then after some time, it creates unintended side effects. The fix effective in the short term has unforeseen long-term consequences. So here is an example. If you try to solve your cash problem by borrowing money, that means going for a large number of credit cards, you to resolve your monetary crisis. Your cash problem will go away in the short term. In the long term, your debt situation will increase and you might fall into what is known as a debt trap. All right, so borrow money to make payments doesn't work. Cut back maintenance schedule to reduce costs, right? When your operating costs are high, you try to cut back maintenance. So this cutting back maintenance, in the end of the day, leads to more maintenance problems. Many years earlier, there was a very popular flight called Air Deccan. Is it not? One fine morning when I was going to, I think, one such place like Hyderabad or Chennai, I was going through the Air Deccan, their book. The book was very clearly saying, they're bragging that we are such, air system. We are always on air. Out of all the airlines, we are that airline which is always flying. We are spending the least amount of time on the ground. So I was questioning myself that is it a good thing or is it a bad thing? Because when you are spending less and less amount in the ground and you are always on the air, are you not cutting back on maintenance? So if you are cutting back on maintenance, invariably you will find your maintenance problems are going to go up. So nothing to brag about the when you are an airlines company that you are always on air. Your utilization of air time is maximum. You spend very less time on the ground. That's not a good thing. That probably is also a bad thing, right? Whether you are cutting back on maintenance or not, that is to be really seen. And invariably, that will relate to various. Suppose suddenly a particular aircraft develops a snag because your maintenance schedule is not exactly followed, not that rigorously followed, you are going to lose money in a big way. So here is the behavior pattern that actually can happen. The fix that you apply. So as your problem symptom goes up, you apply a fix, right? The problem symptom goes down. But next time, the problem symptom becomes even bigger. So again, the fix will help you, but again, the problem symptoms become even bigger. So it goes up and the unintended consequences increases rapidly, exponentially. That's what happens in fixes that fail. A bigger thing is the shifting the burden. So I was really talking about that safety problems. Invariably, when you focus more on the symptomatic solutions or fix, your fundamental solution becomes weak. So when you have a problem solution, either you can go for symptomatic solutions like fix to resolve it, or you can go for fundamental solutions. But then that fundamental solution is require some time. As I said, that time is something which is not available. Everybody wants everything tomorrow. Not tomorrow, today, or maybe yesterday. So when you want everything yesterday, not even today, there is no time before anyone. So if you don't have any time for anyone and you have to resolve the problem situation, it is always, tempting to go for the symptomatic solutions or the fixes rather than really wait for the fundamental solutions. So when the fundamental solutions are ignored, invariably the unintended side effects will come in and that will make the fundamental solutions even weaker. So it has happened in many companies. See, many companies, including several academic institutions, they have gone for outsourcing their IT needs. When you outsource, if you recall 20, 30 years back, I could see that every good company has got their own IT units. Today, own IT units are not seen anywhere. Everybody have outsourced everything. So when you have outsourced and you calculate, oh, look here, if I outsource, I'll gain this much money. So everybody has gained a lot of money by completely outsourcing their IT activities. But today, what is happening? Today, you don't have your IT capability and you are a complete prey in front of your, the IT companies. The IT companies are, whatever they are telling, you have to simply agree. Look here, if your payroll has to run, this much money you have to spend. You have to buy a new Oracle system. You have to buy not only a new DBMS, you have to revamp your computer systems. Since you are now IT novice, you have perhaps no idea or you have no option but to agree. So that's what is the shifting the burden says, that as underlying problem generates symptoms that demand attention, the problem is difficult to address shift the burden of their problem to other solutions, which are easy, well-intentional fixes. The fixes only ameliorate the symptoms but leaves the problem unaltered. The problems grows worse and ultimately goes out of control. All right, so like increasing manpower to improve productivity problems. But sooner or later, if you do not go for process improvement, your product quality will suffer. Right, so that's what happens. So I gave that example of increasing IT needs, and you go for outsourcing rather than develop your own IT expertise. So what will happen? Your IT capability will be reduced so much that you probably will never be develop your IT expertise. Today, IIT Kharagpur has taken a departure. It has developed its own ERP, and as a result, that ERP is now we are now working as people to whom others are outsourcing their activities. So here is that as the symptomatic solution goes up, fundamental solution goes down. All right, that's the essential behavior pattern of shifting the burden. Here is the drifting or the eroding goals. What happens in the drifting or the eroding goals? Supposing you have your safety goals, which are high, there is a high standards. Your safety standards are quite high. All right. But then problem is your actual safety situation is not that good. All right. So there is a gap. So this gap can be filled up by investment in safety. And after some time, see, this time is always important. And after some time, your actual safety will go up. So that's the balancing loop. But the problem is that in the meanwhile, there will be tremendous pressure to adjust the goal. That means, erode the safety goal. Okay, there is no need to really have such high standards. When zero point 0.3 is acceptable, why achieve 0.5? Let's be happy with 0.45, something like that. So safety gap is adjusted by lowering standards while it takes time to improve actual safety. Is it all right? So here is another example, similar kind of example, and revenue. And these can be found out from the systemsthinking.org site. Is it not? You can click on this link and you can get many such examples. All right. So short-term solution involves letting a long-term fundamental goal decline. Early warning symptoms, it is okay if our performance standards slide a little just until the crisis is over. Is it all right? So what should be done? Hold the vision. So some of the examples, I have already discussed some of them. So this is really what happens. As you know, over time, the actual goals decline. As the goal is decline, actual behavior is also declining. So slowly, you are happy with a reduced goal scenario. All right. Now, three such examples I would like to give, although there is not much time, but I may just take around 5 to 10 minutes. One is, this from this paper by, some MIT Department of Aeronautics and Astronautics. They have developed some archetypes. There are several papers on archetypes in the literature. I have seen some recent papers also, but this paper is slightly old. But I will just cover one or two such slides that they have shared. And the remaining two examples, one is our recent paper that Virupakshi Bagodi and myself, we have written a recent paper in Kybernetics journal. That paper, what we did, I will discuss. And third, on some other safety related work that we did some time back. All right. So here is a loop that is unintended side effect of safety fix. So just now we talk about drifting or eroding goals. So this is what happens. So safety problem, if you go for safety fixes, it will create unintended system reaction. So they have also told similar things. Then fixing symptoms rather than root causes, right? So there is a particular accident, there could be a symptomatic response, or there could be actual solution, that is attack root causes. All right. So what happens? Most often, you go if you by mistake instead of attacking root causes, you go for symptomatic response. There will be side effects which will make the attacking root causes even more difficult. All right, then here is another situation. So oversight, right? Complacency in safety system. So sometimes what happens, you create. So if there is an oversight, the idea is that yes, you should monitor the risk, training and certification, inspection and monitoring. So after some time, the risk will go down, and as the risk will go down, the accident will also go down. But then, if that is not there, if this side of the loop is not there, if there is a pressure to the budget, then perhaps the accident rate will create an anti-regulation sentiment, and this sentiment will create a scenario of oversight, right? And that oversight loop may dominate instead of the monitoring risk, you know, kind of situation. And why that should happen? When you are complacent, look here, nothing is happening. Why bother to spend so much money on training and certification and inspection and monitoring? All right, so this is also another such loop. Let me quickly come to the our work that we did in the recently developed paper. So this is that paper on drifting goal systems archetype, drifting the goals archetype, a systemic study in the Kybernets, and this is the link. This has just come very recently. So in this paper, what is really we are talking about? We are really talking about a service center. A case study from automobile service center has been taken, and what we really find out that this is how the drifting goal kind of thing is happening. So the service capacity that we have, we understand that service capacity is not sufficient, right? As the service capacity is not sufficient, to really improve upon the service capacity, we must take capacity addition decision. And however, just taking capacity addition decision will not help. It will take some time before the service capacity will be really improved. In the meanwhile, there will be a pressure to cater services, and therefore this can only be done by reducing the service time. That means a particular four-wheeler will require certain service, and that service also requires certain time. Now we are trying to, because we have lack of capacity, what we are trying to do, there is a pressure on us. I mean, nobody is giving pressure. We are putting pressure on ourselves by looking at long queues of automobiles, and by seeing that people are unhappy that why should I wait so long? If I go to other service center, I never waited so much. So by hearing all those dialogues, we are prompted to reduce the service time and quickening our work by not giving the best possible service. So the kind of loop that we have developed is something like this, that here you see that we have certain kind of situation that desired capacity and indicated skilled labor. So there is one kind of service that is about the skilled labor, right? So are we having this all the different kinds of skilled labor that we require, whether we have them or not? However, you know very well that getting good quality skilled labor is not easy, right? When you have good quality skilled labor, they leave the job also. So you have to continuously do the skilling programs, continuously do the training, and those are also time-taking incidents. So only then your service capacity goes up. But in the meanwhile, there is a work pressure, and that work pressure is reducing the time per vehicle, and therefore the vehicle service per day, and that has an impact on the service rate and the vehicle waiting. So these are the major loops that we identified, and we saw that due to those situations, the service system is having difficulty. So additionally, the drifting goal subsystems archetype in action, the service quality goals are further lowered because of two additional loops. One is that of the waiting time. Waiting time increases, and the second is the work pressure, right? So one hand the work pressure increases, and that is that perceived service quality, and the other one is through that waiting time, right? So causal loop diagram for the automobile service system with perceived service quality and waiting time. So while the long term answer is improve the service capacity, in the short term we find that both waiting time and the service quality, they are both suffering because of the additional focus on the the service to be given on a given time. Now, what it may result into? It may result into several difficult problems which may suddenly occur. Right? There could be mechanical difficulties that might remain. There could be faults. There could be even safety concerns which may come in with time. Now, safety dynamics, the another case study which we also took up some time back. There we have studied the unsafe conditions in the workplace. So unsafe condition remedy, and the total unsafe conditions that we have developed two different balancing loops. Thereafter, we also developed the dynamics of the knowledge system. There we found out how the knowledge system for safety really grows with training and similar kind learning systems. And then we found the how they see incident reporting is also another very big thing. And whenever there are unsafe acts, the incident rates goes up, and incident reports keep on coming in, and that is also required that incident reports to be processed. So that's the dynamics for unsafe acts. And the incidents on the other side, what is really creates is further unsafe conditions. So those are the different kind of thing, and thereafter we did the detailed modeling. Those are all here with regard to various parts, that is unsafe incident generation, unsafe acts identification, unsafe conditions identification, incident reporting, manpower modeling, safety knowledge system, and the complete case study. Right. So that is all that I thought let me share today about this specific lecture. Right. So thank you very much. And I hope, at least I could generate a little bit of interest in all your minds about the systems archetypes and how the system archetypes and the systemic ideas can really help, and if not anything, at least bring some systemic issues into our thinking. Before ending, let me just say this much. Most of the time, we focus on fault finding. We really do not understand that the kind of faults that we are finding in the real world, it is the systemic scenarios, it is the systemic feedback loop processes which is creating that kind of situation. So instead of focusing on fault finding, the focus should be on identifying the various feedback processes and try to see the root causes, what is causing those systemic feedback loops, and alter those feedback loops by suitable interventions. Please also remember that a chain is as good as its weakest link. But finding that weakest link is not something easy. It's very difficult. Finding the root cause is not really easy. Identifying root cause and really focusing on the root cause and leveraging on them, that is where the real action can be found out. And that is when you will be really benefiting from the feedback loop studies. Right? So that's all. Thank you very much.
Thank you, sir. Thank you for this wonderful lecture. Now we have several questions. We'll take one by one.
Yes.
So first question is, some delays, maybe they are between the effects. So can you put some light on this one?
Ashish,
I'm
you are
really
not
sorry.
clearly audible.
Certain words got cut, so I could not hear completely. If you kindly repeat once again.
Yes,
Ashish,
sir.
your
Yes.
voice is not clear.
Hello.
Your
Yes,
voice is not clear
Is
now.
it clear now?
Yeah.
Yes,
Now
yes.
okay, now
Please
okay.
tell.
Yes. Yes, sir. So the question is, there may be some delay. Some delay may be here between the effect. So can you put some
Okay.
light on this? Yes,
Oh,
sir.
no, Ashish, you are not audible properly. So Shobhik and anybody else can take care.
Yes, sir. Yes, sir.
You start. Okay.
Yes, sir. Thank you, sir, for this wonderful lecture. So, sir, we have some question in the chat box. Like, sir, how decision analytics can be used to improve risk control system?
Okay. Okay. See, I mean, this question is a very good question. And specifically when it comes to risk analysis, see, the risk analysis, let me give the answer irrespective of my lecture. Because, see, I gave lecture on one part of the whole thing. But then that doesn't mean I have to only answer through that only. See, the risk analysis essentially requires understanding the entire scenario which is generating the risk, right? So that process has got various interventions, and that process has got various kind of behavior patterns. So if we understand each of them, that what are those behavior patterns, and then we really can simulate either in our mind or through maybe any kind of virtual reality or simulation or any such method, then we can generate that what are those risks. Sometimes even very basic sensitivity analysis can help. You have some behavior variable values. For example, let me give a very small example. Every day I go for work, and just near our gate number 5, they have made some the indicators, some kind of metal indicators. They say that IIT Kharagpur this side. That height is just exactly my height plus 2 inches. So every day I go below that without even bothering that it is there. I don't even care. I simply go and below that, and it never hits my head. But really speaking, yesterday I realized that it is hardly 1 or 2 inches, or not even that. So I escape it every day. You can think like that. So if one day, if I was having a particular spring in my foot, I might actually hit that particular thing and have a small accident. Now, question is, what is the risk of me having that accident? See, my height is not going to increase at this age. So the question is, I will hit that particular board, which is just hardly half inch or 1 inch above my head. If there is a small sensitivity factor, like, I put a different shoe, or I may be a little jumpy on that particular day, or something has happened that it has lowered just half inch, I will simply hit that because I really don't bother at all about it. So question is, sensitivity of the parameters, even a small change here and there can create a risk situation unbelievably, which you never thought. Let me give a very, very ordinary example. See, in my room, there is a door. All right. So somebody comes in my room and they simply knock, they don't come in. So what you do? You try to go out and open the door. So by the time you are opening the door, at that very moment he pushes the door at a very big speed. What will happen? The door will hit you and you may fall down. So an accident happens. The question is, what is the risk? You may say that will never happen, but it can also happen. There is a chance. So therefore, all these sensitivity kind of situations has to be analyzed, right? So that's the basic answer. And now the question is, if you want to do system dynamics model for that, that you can do. You can also look at sensitivity issues. See, now we have this AnyLogic software. The advantage of AnyLogic software is that even for any kind of system dynamics model or a discrete event simulation model or agent-based simulation model, it has a capability where you can do sensitivity analysis in a very, very big way of all the variables, not just any variable. And you can generate all entire spectrum of the, the behavior patterns. So risk analysis in every field is a very, very interesting area, and a lot of very good work is possible on that.
Yes, sir. Yes, sir. Thank you, sir. And the next question is, what will be the impact of introducing additional resources on a feedback loop?
Okay. See, first of all, you have to understand that why that feedback loop is existing. Something is a cause, something is an effect. Now we have to see that is it a sufficient cause or is it not even a sufficient cause? So when you say A causes B, something like we are saying that price to demand, right? Now more price, less demand. But suppose everybody is having huge amount of money, right? Everybody is having in a particular place, money is not at all an issue. So if so much resource is there that everybody has got enough money, then how price will affect the demand? So that's the kind of thing. So there could be obviously resource is going to change certain causality. Possible, highly possible.
Sir, yes, sir. Thank you, sir. And with your permission, I am taking another question.
What about the delay question that I really could not understand? He's really talking about that. Is it the question is what is the effect of the delay?
Yes, sir. Yes, sir. It is actually talking about
You
that.
see,
What
delay is a very important component in any kind of systemic issue. I really could not see. He could say that yes, there is a delay, but what is the effect of delay? Is it like that?
Yes, sir. Yes, sir. That question is like that. Then, sir, another question is there, sir. Then
Yes,
how
yes.
can we model the system dynamicity using Industry 4.0 like such as AI and ML techniques? Yes, sir.
Exactly what I was trying to tell you that whenever we are developing a cause-effect model and we are developing a feedback loop, is it not? Now the feedback loop will generate some kind of behavior pattern. Now the question is, this particular behavior pattern which you have generated, this essentially, see, there is a particular entire issue of European Journal of Operational Research. What they are calling is models for learning. Now, see, there is a big debate. The kind of behavior that you are generating, is it a forecasting? Is it a future projection? Or is it only for learning? So most often the answer is basically it is nothing but scenario building. So if you can generate different scenarios with different kind of variable patterns, you have really generated a lot of data and lot of scenarios in a given situation. So these data that you can now input and you can try to interpret these data in a given situation. So that is what I believe that in an uncertain situation where cause and effect is not easy to find out, AIML can help in interpreting the situation, and after a little bit of interpretation has been obtained, cause effect models can also be built.
Yes, sir. Thank you, sir. Now I would like to invite Professor Krishna to formally provide vote of thanks to our expert speaker. What do you say?
Savik, please unmute all.
Yes, sir. Yes, sir. I am unmuting all.
Because lot of academicians, lot of
Yes,
industrials,
people
many people are there.
Yes, sir.
I'll allow one question, direct question from the participants to Professor Mahanti.
Yes.
Anybody want to ask? You are unmuted. You can ask the question to Professor Mahanti. Have you unmuted the?
Yes, sir. Yes, sir. Everyone is unmuted.
Hello.
Yeah.
Yes.
Sir, am I audible?
Yes.
Sir, I have question like you have shown us various examples of the feedback loop, like positive feedback loop and negative feedback loop. So my question is that as you are giving the example of the cells and the increase of the positive marks from the people, so which element should be focused more? Like we have to shall we have to given importance on this more importance on the cells, or should we give importance on the people, like should we advertise our whatever the components or the whatever the elements that we are producing, should we advertise that more among the people, or should we give importance on the cell?
Okay. Let me answer this. See, when we see the feedback loops, sometimes it might create a wrong impression in our mind that those feedback loops are just, we think and put some positive or negative loop. Unfortunately, no, that's not the thing. Let me give a practical example. Suppose you have an 1 year project. If you have an 1 year project, 9 months to 10 months time you should spend on the conventional analysis, reading books. See, basically data collection processes are threefold. You can collect data either by literature survey or by expert opinion or by running different kinds of models like AI/ML models or statistical models or any kind of other kind of models. Through that you generate inferences, generate scenarios, and generate knowledge. So, 9 to 10 months you should generate your knowledge. Only after you have generated enough knowledge, only then you should really try to develop your causal loop diagram. All right, at the 9 or 10 months later, if it is only 1 year project. On the first day itself, if you try to develop something, that is only could be a textbook exercise. See, we are teaching these courses, so obviously the students are not doing projects of that type. So we do certain things for classroom exercise. The classroom exercise is one thing, serious work is another thing. If you are doing serious research level work, you must spend huge amount of time in getting data, interpreting ideas, interpreting knowledge. Now you see these kind of thing, that is advertising and sales and other thing, it requires very great knowledge of marketing. So only after generating that, what kind of market you are talking of, what kind of advertising you are talking of, what kind of sales you are talking of, every situation is different.
Okay, anybody else want to ask a question to Professor Mahanti?
Sir, good evening,
Yes.
sir. Somen
Yes,
Roy
yes.
this side. Sir,
Tell me.
sir, you know that you have talked shifting the burden. So whole world has shifted their burden to China for manufacturing it. And now this COVID effect, people have seen, whole world has seen it. What is the effect? So why this whole world did not think about this cause and effect or a causal loop in advance? That's what I want to say, sir. What is your comment?
See, one thing is that a lot of people forget about this. This is, you are asking a very big question. Let me even take this, projecting that epidemic growth, that all the models have actually failed. Even very recently, the IIT Kanpur model has also failed, because IIT Kanpur has projected Omicron in a certain way, the reality is happening in another way. So the point is, see, the difficulty is because the reality is far, far more complex than we think. Because of huge complexity in the world, for when you are modeling, you have to be very careful about what are the variables you are talking of, what is the level of knowledge that we have. If we do not have knowledge, if you do not have expertise, our models will be also like that. So it is like garbage in and garbage out. If this is the only thing you have collected, it will be garbage out only.
Okay.
Thank you, sir.
Thank you. For every good talk, we should bring to an end. Professor Mahanti, let me tell you one thing. The students, when they hear to your lecture, they feel very, very satisfied, mesmerized. Because I was also a student once to your class. with your experience, work experience, some years work experience and great academic career, you made all the participants, including industry participants, really very happy. I'm really thankful to you. And the models which you are given, eroding goals and shifting the burden, complacency, all these things are very, very aptly useful for project safety management systems, safety engineering and management systems. Thank you very much for bringing all these things. With this, I came to a great satisfaction. You can be a great resource to our CoE-SEA. After hearing to you, after hearing your knowledge in the various models interpreting with the safety management systems, you could be a very good resource to whole of our CoE-SEA, which is coming up very well. This time I have seen a lot of students. A lot of students have participated. Really, this sort of lectures will be useful to your career. Otherwise, you will be in the only academics. So this is the club with practical knowledge and all these things. Students, I think you have really enjoyed. I'll see your feedback also. The lot of industry people I have seen, they're also enjoying this lecture, these models and all these things. Thank you very much. Thank you, all of you. And I thank my moderators, Sveen, Ashish, and Savik, for really taking up. That's why when you keep more moderators, when some problem comes, the next moderator take up. You're really shown that agility and took it. Thank you very much. Thank you all of you for participating in the questions, and thank you, Professor Vanti, for giving great lecture. And gentlemen, next week again we'll have a lecture from this time industry specialist, Ms. Atanu Chatterjee from Texmaco Corporate Safety Head. He is going to give a lecture next week again at 8 p.m. Thank you very much. Till that time, take care. Take care of your COVID protocols, follow it, and take care of your health. Thank you all. Thank you, Professor Mathi again. Professor Mathi, you want to say anything?
No, only I just say that thank you, sir. It's a really the different kind of lecture, and probably we will be bringing more of this kind of new thoughts, so that the safety professionals, they will now see that a lot of behavioral in the behavioral safety sides. Many of the models can be used in also the organizational safety management or prevention through design point of view. These ideas basically more important, and I'm extremely thankful to from the CoE-SEA, Professor Mohanty, that all those ideas, all the models and concepts are extremely useful in the safety domain also. We'll definitely take your help and we'll come back to you again.
Right. So thank you. Thank you.
Thank you all
for listening. Right. So, okay then. Thank you.
Thank you.